What is up, everyone? Welcome to the next lesson in the full-time GoDev program. And today we're going to take a closer look at advanced interface mechanics and typed functions. Very important stuff in Golang. I cannot emphasize this enough. Interfaces and basically composability of your program is going to be very important, right? We are going to have, like I said, we're going to make a lot of projects in this full-time GoDev program, and you will see we're going to use them all the time, right? So that's why I'm going to give you another couple of examples. So first of all, let's take a look at advanced interface mechanics, right? So basically, let's say we're going to have a type. We're going to say it's going to be a storage, and that's going to be an interface, right? And we could say a storage, what could it have? It could have get, right? And it's going to be basically, for example, get by an ID, which is going to be an integer, right? And you don't need to specify, you could do like this, get ID integer, and it's going to return, for example, it can return anything, right? Anything and an error, right? That's always a good practice to return two multiple returns, the type you want to return and an error, right? So you don't need to specify this ID here. You could basically just say int, right? But let's do ID. It's a little bit clear, a little bit more verbose, but a little bit more clear, to be honest. So you know we're going to get an ID, right? We're also going to have, for example, let's say put, right? And we're going to put, for example, put ID integer, and we're going to say, we're going to put the value, and it's going to be any, and it's going to return an error in this case, right? And we could say, yeah, that's fine for now, right? So basically, storage is an interface. How are we going to use that? Let's say we're going to have a server, for example. Type server is going to be a structure, right? And this server will basically take a store, right? A store. We can actually do it small caps, a store. And this store is going to be a storage, right? What will basically what's going to happen is that if we create, for example, let's say this one, func. Wait, let's do this. Let's say S is going to be a pointer to the server structure. We're going to instantiate it like that. And then we're going to say S because server has a store. We can actually say S store, and then we can have access to two functions here, get and put, right? So we could say get one, and that's going to return two things. And we could say, for example, S. Wait, what I'm doing here? Yeah, S store put, and we're gonna put to ID1, and we could give it some values. It doesn't actually matter, guys. You could say foo or something. It doesn't matter. The problem is this is not gonna work if we run this, right? We could say go run me not go, and the reason why this we're gonna get a runtime error, invalid memory address or nil pointer dereference, and that's because this storage interface is empty, right? Because we didn't specify it, right? That's because storage itself, this interface, is going to be the interface and not the actual implementation. I already covered this in the interface video, right? So basically, let's say we're going to make a new one. We're going to say type a foo storage. It's going to have a structure here, right? And we're gonna. It doesn't actually matter here. It doesn't matter that's an empty struct. It doesn't really matter. We're gonna say S is going to be a pointer to a foo storage, right? And we're gonna implement this get method. ID is gonna be an integer, and it's gonna return any or an error, right? And in this case, we're just gonna return double null, right? Null here and null here, because we don't actually care about the implementation. We're going to copy this, and we're going to implement the put function here, put. And that's going to be ID, any. It's going to be a value, actually. And the value is any. Please, any. Font is huge, not going to lie. And this is going to be an error. That's fine. And we're going to return null. Cool. So the next thing we could do, basically, is if we instantiate the server, we are going to say that the store of the server is going to be our foo storage, right? So we could say n foo storage, like this, and then we could say go run main.go, boom. And it's all fine. Everything is working pretty fine, right? But So we can run into some issues with this TS disable highlights real quick. TS disable highlights, boom, just like that. Look at this. Beautiful. Okay, cool. So let's say this storage interface here is basically going to have a couple of functions, right? You could get, put, delete. We could get user this, get book here. You can basically make this interface way too big. And in Golang, you're going to try to keep your interfaces as short as possible, right? For example, let's say we have any arbitrary functions here. And we have a function. We're going to have a function here, for example. Let's say func update user, for example, or update value, right? And this update value function is going to take in, well, let's don't do it. Let's do it like this. Update value, we're going to return an error because it's always a good practice. So update value. And we are going to say, for example, that inside of this function, we are going to say that we're going to instantiate our full storage, right? Or storage, store, and that's going to be a full storage, right? And then we could say store, for example, put, right? We're going to put, let's do val ID here, integer, val any, right? And we could say here ID val. And we could return this because store put returns an error, right? So update value is a function that is perfectly fine, right? It's gonna work, but you can already see the problem here with update value. And the problem is that we basically have an dependency inside of our function, right? And the dependency we have is the full storage, right? Is the full storage. So that's why interfaces are very important, because you could basically, the problem is if you're going to test this function, this update value, which tests, we're going to cover that in the next, probably in the next lesson. But the problem is that this function, this update value, has a dependency, a hard dependency, and that's the full storage. Right? We always going to create this full storage with its implementation. And there's nothing we can do about it. Unless we use the power of interfaces, and instead of updating value here, you could say ID, actually, to be honest, like this, ID val any, and we could give this, for example, a storage, right? Or a store, and that's going to be a storage, right? So right now, we're going to do some dependency injection, and we're going to inject a storage. And that could be anything. It could be a full storage, a bar storage, whatever, because we could have this, right? We have a full storage here. We're going to copy this, right? We're going to paste that in, and we are going to say that this is going to be a bar storage, and a bar storage. Of course, these implementations stay the same, but you could change them up. Maybe some storage is using Postgres, another storage is using MongoDB, maybe another storage is for testing, which is going to be an in-memory store, because it's easier. You don't need to connect over the network with a memory store. You can just do it in memory. So we have a storage here. So instead of basically saying full storage store, we can just return store, right? Because we are 100% sure that this storage is implementing the put method, right? Much better. So instead of doing this, we could basically do something like that, update value, and we could say s store, for example. And then we're going to say one full, I don't know, just a value. It doesn't matter, right? And this is going to be perfectly fine. But we can make this even better, right? We can make this even better because, and that's very important, right? Because, you know, like I'm trying to build things up, no worries. So we have this update value, right? This function. It could be anything, right, guys? Listen, this is just, I'm trying to give some examples, right? And it's close to, it's basically close to what's going to happen in the real world, because the thing I'm going to explain right now is something I used in a project, right? Where I needed to update a value, where I needed to use put, and I refactored my interface so it's a little bit cleaner, right? So update value. What do we know with update value? Well, we know that we're going to update, right? We're going to call a store put. But store is a storage. So it basically means that it's a dependency, it's a big dependency, right? Because maybe the storage is going to have, for now, it's only going to implement get and put, but maybe it's going to implement delete and update here, update there. It could have 20 implementations, and you're basically going to inject an interface with 20 implementations, 20 function methods attached, but you only need one, right? So how can we do that? Well, we can do something like that. We could say type, and we're going to make this a putter, right? And that's also going to be an interface. And what will a putter do? Well, a putter just going to have a put function. To be honest, let's just delete this here, paste it in here, and now we have a putter here, right? A putter interface, and the only thing it's going to do is put. Easy peasy, right? So instead of doing update value, right, we are going to say basically, and I think I have basically a new look at this camera. I think it's more frames right now because I have some new stuff. Anyway, jokes aside. So instead of doing a store, we're going to say a putter, right? And a putter is, or P, you could say P putter, right? Why not? And it's going to be a putter interface instead of a storage, right? And instead of saying store put, we're going to say P put, right? It's perfectly fine. Actually, let's make this putter like that, to be honest. P is fine, right? So right now, update is going to work. So the problem is, right now, we could say, for example, well, the problem right now is that cannot use store a variable of storage as putter, right? Why? Because storage doesn't implement putter, right? Because we deleted putter from storage here. So how do we do that? Let's say we want to, we basically want to put the store as the putter interface. The storage interface as the putter interface. How can we do that? Because it doesn't implement put. Isn't this complex? I know. But actually, to fix that, you could say, oh yeah, that's actually easy. The only thing we need to do is copy put back in here. And now it's going to work, right? Look at this at main. No issues anymore. But that's bad. Because right now, you have 2 times the put. So you could delete this. And instead of writing this method in here, you could say that the storage interface also needs to implement the putter interface, right? So every storage, everything, every entity, every piece of every atom of the universe that is going to implement the storage interface will also need to implement the putter interface, right? And you see, now update value, store, we can just put a store in it. Why? Because store, this interface will guaranteed only also implement putter, which is put, right? So to make this even, to give you an example, let's say we're going to say type simple putter. It's going to be a struct, right? And we're going to implement this method. So we're going to say func as pointer simple putter. Could not be a pointer, but it is what it is. Don't worry about that. We're going to cover that. As simple putter, we're going to say put. What's going on here? Put is going to be id int any val any error. We're going to return null, right? So this simple putter implements the put interface, which basically means that it's a putter. So that means that what we could do is, for example, we could delete, let's zoom in here. Let's delete the server. Let's say as putter, which is going to be a simple putter, right? And we could basically do as putter in here, right? And it's going to work perfectly fine. Why? Because as putter is a putter. Storage is also a putter, but it's also a storage, right? So that's basically some advanced mechanics. It's basically interface embedding, right? You could embed an interface into another interface, so they also need to implement that interface, if that makes sense. And you can basically take this very far. You could say this also needs to implement the FMT stringer, for example, FMT stringer, which needs to implement the stringer interface. And it's not going to work. Oh, wait, let's say, let's do it in putter, like this. Whoa, boom. And then it's not going to work because this, or sputter, right, or simple putter, basically does not implement the stringer interface, and you could easily do that by just saying func simple putter string, which is going to return a string, and we could return an empty string or something, just like that, just to implement it, and you can see now it works pretty fine, right? Okay, so the next thing is basically what I want to talk about is typed functions, right? Typed functions. So what I'm going to do is I'm going to delete this whole shebang here. Boom, it's all gone. Func main. Just like that. So basically typed functions is the same thing, right? So what we could do is, for example, let's make a function here, func. And what could we do? Transformer. Transform string, right? Transform string, and we're gonna give this as string, and we're gonna transform this into another string, right? So basically, let's say transform string, we're gonna do, how can we do this? Return strings to upper S, right? So what's gonna be is we're gonna say fmt print ln transform string, and we're gonna say hello sailor. Boom. What's going on here? Cannot use, yes, it's true, because I don't do single double quotes. Go and may not go. So basically what's going to happen is, you see hello sailor, we're going to give it a small cap string. It's going to transform that string, and we're going to hard code here strings to upper, right? But that's bad, because why is it bad? Because we have a big dependency, and that is the implementation of transform string, right? Maybe we want to transform the string into, for example, a prefix, right? Maybe we want to append or prepend a prefix or a postfix. So how are we going to do that? Well, we could say transform this string, but also give me a we're going to say fn from function, and we're going to say that's going to be a transform func, right? And what we're going to do here is we're going to say return fn string, right? So the problem is it's going to say undeclared name transform func. So we're going to do that. We're going to say type transform func is going to be a func, actually, to be honest, like this, is going to be a func which will take in a string and it will return a string. That's a transform func, right? So right now we could say transform string, and we need to give this a function, a transform function. So let's say we're going to say, let's implement some transform func, right? So we're going to say uppercase. We're going to say uppercase as string returns a string, and we are going to return strings to upper S. Boom. Undefined strings, why is that? To upper like that. Boom. Right? So right now we could say transform string, hello sailor, and we're going to say uppercase. So if we now run this, go run main.go, boom. It's an uppercase hello sailor. Very simple. We're going to make another one, right? Let's say we're going to do func prefixer. Prefixer. Well, it's the same thing. It's going to be a transform func. So we're going to say s string is going to return a string here. And we're going to say return foo, that's my prefix, underscore plus s. Like that, right? And the second thing is going to be our prefixer here. Prefixer. Boom. Let's run this again. Boom. You see? We have our uppercase transformer, we have our prefixer transformer, and you can make as much transformers as you want. So, the last thing I want to cover basically in this thing is, it's very important, right? This is very important stuff in Golang. It's very important to know, and you could basically give your typed functions in as an argument, but you also could basically store your typed functions, your function types into structures and all that stuff. Right? But you're going to see that later on. This is just an example. Another thing, what's important is, for example, this prefixer basically has a dependency. Once again, this is programming, guys. Listen very carefully. This is programming. this is a hard-coded prefix, and we don't want that, right? We want that our prefixer will take in a string and a prefix, right? Prefix, which is also going to be a string, right? And it's going to return basically this, the prefix plus the string. Easy. The problem is that this prefixer, we cannot use this, right? Because a transform func only takes in a string. But our transform func takes in a string and a prefix, right? So how are we going to fix that? Well, we're going to fix this by saying that we are going to take in a prefix. Let me quickly think about this. We could do something like... now I need to think about this. It should be a transform func. We are going to return a transform func here. That's what we're going to do. We're going to say here, transform func. We're going to return a func which will take in a string, and it will return a string. So we're going to say that this prefixer will do this, right? And it will basically take in a func. It will return a function, because the transform func is this one. So we're going to return the transform func. So we have access to this prefix. We're going to decorate this function, and then we're going to do that. So how we're going to do this is we're going to say prefixer, and we are going to say prefix this with foo, right? That should actually work. Let me see. What's going on here? Go run main.go. Boom. You see? It's prefixed with foo. And we could actually do another prefixer. But let's prefix this with bar, for example. Right? Boom. Now we have a foo and a bar prefixer, right? This is important. You see this? This is how you can utilize interfaces and typed functions and composability and decorator patterns to program and to have zero hard-coded dependencies and inject everything based on your likings, right? That's programming, right? So you could reuse these things over and over in your application without the need to basically change the actual implementation, right? Very easy to test. Very easy for your colleagues, very easy for yourself. It's just the best way to approach programming in general. All right. I think this was it. We discussed basically some little bit in-depth interface. There is a lot more into interfaces, but like I said, I don't want to overburden you with all that jazz. So that should be fine. You basically already know more than a lot of Go developers, trust me, with these things. And then we basically also discuss typed functions because they are very important. So you could say, yeah, but when do I use typed functions and when do I use an interface? Well, you use an interface if you basically want to have state, because a typed function here, right, this transform, there is no way to store state, right? But in an interface, if you have an interface, right, you could say type foo interface. You basically can make a struct, right? Type foo implementation. It's actually so bad, but it is what it is. Foo implementation is a struct, right? That basically means if this foo implementation implements foo, you could have in the struct state, right? And that could be whatever state you want. Could be an integer, it could be a string, whatever, right? And you could have multiple things. So that's basically the rule of thumb. If you, for simple things like a transform function or these stateless pure functions, use a typed function. If you really need to have state or something, use an interface, right? Cool. Thanks for watching, and I see you in the next lesson. Peace.